In this video, I'll show you how to use GeoGebra to find the area between two z-scores on a normal distribution. So first, let's go to the website geogebra.org/classic#probability. On the two tabs, you'll see distribution and statistics. Choose distribution and make sure that normal is chosen from the drop-down box. There's a number of options down here, but you'll want the normal distribution. You'll also notice that mu is automatically set to 0 and sigma is automatically set to 1, so we have a standard normal distribution. We can change the normal distribution if we need to, depending on the problem. So let's go back to a pre-worked example that I have. According to a study, the average number of faces an adult can remember, recall the face and remember the name, is 150. Let's assume a population standard deviation of 30 faces and a normal model. So what we've gathered here is that we have a normal model, the standard deviation is 30, and the average number of faces that an adult can remember is 150. So let's change our normal distribution to have a mean of 150, a standard deviation of 30, and we have our normal distribution. All right, the question says, what percent of adults can remember between 125 and 200 faces? So 125 and 200 are the cutoffs for this region that tell us the percent of people that fall into that region. So on our normal distribution, we need to change the two endpoints down here in the bottom part of our graph. So the bottom left part of GeoGebra tells you which side you're going to be finding your area in. If we click the left side, we'll be finding percentages to the left of some cutoff, or we have a between where we have two cutoffs and the area between is found, or you can find the right cutoff. We're going to choose the between option and then put in our two cutoffs, which were 125 and 200. So I'll click in the boxes, 125, click in 200. Make sure to push enter to make sure to lock that in, because sometimes the probability changes. It uses the last answer. All right, so the probability that between 125 and 200 faces are remembered by a person is about 0.7499, so about 75%. You can also see the little black triangles that are the cutoffs for that region and say, oh, that looks about like 75%. Sure, I believe that. Here's what we would do if we were working by hand. First, we would draw our normal distribution with a mean of 150, a reminder of standard deviation of 30, and then here's our cutoff, 125 and 200. I've shaded that region. I also already put in the answer because I completed the problem yet. So step 2 would be to find a z-score for each cutoff. So a z-score for 125 means 125 minus the mean of 150, find the answer, divide that answer by 30 to get negative 0.83. So on a standard normal curve, negative 0.83 is analogous to a cutoff of 125. Step 4, let's find the z-score for 200 faces. So we'll take 200 minus 150, get that answer, divide it by 30. Remember your order of operations. Subtract first, then divide. We get a z-score of 1.67, and I had to round that out. So here's a z-score of 1.67. It is on the right side of the curve, and you can see this white section. That is the area between negative 0.83 and 1.67. So the way you have to work this by hand instead of on GeoGebra is you need to find two areas under the curve, subtract them, and then the answer is what's left in the middle. So finding the area to the left of negative 0.83, it's the area in the tail. It's actually not directly the answer that we need, but we know the area in that chunk. Then if we similarly go to the normal table, find the area to the left of 1.67, so my little arrow says this is the area to the left of 1.67, we get an answer of 0.9525. Now again, that's the area totally to the left of 1.67. It's not really the answer that we're looking for because we need to find the area between the two z-scores. So then we say, well, The area to the left of 1.67, that's too much. It does include the middle chunk, but it also included the tail area. We don't want that area in our actual answer. So we will take that area in the tail, which we already computed, and subtract it from the 95. So 0.9525 minus 0.2033, because that was the area in the left tail, that difference is our answer, 0.7492. Now let's go back and compare that to GeoGebra, because we got in with GeoGebra 0.7499, working by hand 0.7492. They're pretty close. There is going to be rounding error when you're working by hand because your z-scores had to be rounded before you could get to your answers. So the answers will seem pretty similar. If you need to, you can always use more decimal places. You can also use more technology that would allow you to get more decimal places. But with a table, you're limited to just 2 decimal places. I tend to like the technology because I can put in the exact numbers and the exact mean and standard deviation. I don't need to translate into z-scores. And working with GeoGebra, you just directly put in your numbers. There's no z-scores at all. When you work by hand, you have to go from the original data, turn it to a z-score, get an answer. So there's that middle step of z-scores that bring in some possible room for error. Just a tiny little bit in your final answer. So there you go. That's how you can use GeoGebra to find the area between 2 values on a normal distribution.